So, uh, so every architecture of microcontroller basic component will be your CPU. Okay, so first we are going to see the CPU architecture. So here, what type of architecture used is nothing but hardware architecture. One Newman, like that you are having many types. So in that you are using hardware architecture for the CPU to achieve the fast execution period or speed for a given clock rate. Okay, for that purpose only we are going to use hardware architecture in the PIC family. Here instructions are fetched from program memory using buses that are distinct from the buses used for accessing variable. So here we are going to use bus for fetching the program memory device. Okay, what we are going to fetch instruction. Okay, to fetch the instruction we are going to use the bus from the program memory. So that is represented in the diagram. This is your hardware architecture. This is CPU. This side you will be having program memory where the instruction will be stored. Here, the special purpose register as well as data memory, that is RAM memory. Okay, so how address and data are interchanged or fetched by the CPU from the program memory as well as data memory is given here. So every instruction is coded as a single 14-bit word and fetched over a 14-bit wide bus. That means here your bus can able to fetch only 14-bit wide instruction. That is, every memory device will be holding capacity will be 14-bit. That's why your bus range also only 14-bit. So consequently, an instruction. பாப்பு போ பின்னாடி போ சவுண்ட் கேக்குது போ பின்னாடி போ பின்னாடி போய் உட்காந்துக்கோடா சவுண்ட் பயங்கரமா கேக்குது கிளாஸ் எடுத்துட்டு இருக்கல அம்மா குறைச்சிட்டியா பேசவும் கூடாது Okay, consequently, as instructions are fetched from successive program memory location, a new instruction is fetched every cycle. I think you all know the pipelining structure or pipelining technique, which is already studied in your 8085 microprocessor. This technology is applied in 8085 microprocessor itself. I think you all know what is pipelining. So while you are accessing the second instruction, the first instruction will be executed so that you can minimize the timing. Okay, timing cycle of your instruction execution. Okay, so execution time will be minimized due to the pipelining techniques. Okay, so yeah, during the fetching of second instruction, your first instruction will be executed. So what are the process involved in execution? Fetching and then execution. Okay, fetch, execute. So while you are fetching the second instruction, the first instruction will be executed. So that each and every instruction will take only one cycle for executing the single instruction. Okay, this is the pipelining technique. This was applied here. Okay, the CPU execute each instruction during the cycle following its fetch. Pipelining instruction fetches and instruction execution to achieve the execution of one instruction every cycle. This illustrated in the diagram. I will show that. Wait. It can be seen that while each instruction requires two cycles, that is fetch and then which will be followed by execute cycle. Okay, so fetch execute for executing a single instruction. These two process will be involved. So for fetching purpose you need one cycle and executing purpose you need another one cycle. So two cycle will be required for executing the single instruction. But applying the pipelining method, you will be using only one cycle for executing the single instruction. How means, so while executing the first instruction, you will be fetching the second instruction. Okay. So in that manner, you will be avoiding the cycles. Timing cycles will be avoided or minimized. Okay. So here you will be overlapping of the execute cycle of one instruction with the fetch cycle of the next instruction, which will lead to the execution of a new instruction every cycle. I will show this in your diagram. See here, this is the pipelining of instruction fetched from successive address. See here, first instruction you are going to fetch now in the first cycle. Okay. So while you are fetching, executing, these are the two process involved in the execution of single instruction. Okay, fetching, execution. So fetching process will be done in one cycle time period, then execution of the same instruction will be happened in second time period. So during that time period what will happen, you will be fetching the second instruction. Okay, so in this way you are going to save the time. Okay, so only one cycle will be required for executing the single instruction. Okay, so in a whole second instruction execution time la, you will be fetching the third instruction. So third instruction executing time la, you will be fetching the third fourth instruction. Okay, like this successively it will be going on. Okay, so finally for one instruction it will require only one timing period or cycle for executing a single instruction. Okay, this is the pipelining technique. uh, there are some case where this lockstep progression will be broken. That is while you are executing the branch operation means that a subroutine call, you'll be calling some program, small program or small task. At that time this pipeline technique will be failed. Okay, for example, see here they given an one example. Here the instruction is fetched during the cycle go to a new address whose job it is to be change the normal flow of instruction fetches from one address to the next address. So go to address, that means in the program, okay, you'll be having jump to new address. So at that time what will happen, your current cursor will be jumping to new address, present addressல இருந்து new addressக்கு jump ஆகும். So அதுக்கு ஒரு it will take a cycle. Okay, and then during the third cycle, sorry, during the third cycle the cpu carries out the sequential fetch from address n plus 2. At the end of that third cycle the cpu execute the go to new address instruction by changing the program to counter to new address instead of simply incrementing it to n plus 3. On the fourth cycle, while it is fetching the instruction at new address, it ignores the instruction automatically fetched from address n plus 2. While this n plus 2th instruction is located in the program immediately after the n plus 1th go to new address instruction. It is never executed immediately after the execution of that n plus 1th go to new address instruction. So this paragraph is clearly explained in your diagram. If you see the diagram, then you can be able to understand easily. See here, this is the example of that go to address, that is subroutine program. Okay, so what happened here, you are going to fetch the nth instruction. Okay, and then execute that nth instruction. During that time period, you are going to use the go to instruction. So go to instruction use பண்றப்ப என்ன ஆகும், it will be calling some new address. So for calling new address, you will be fetching that new address from the program memory. அதுக்கு ஒரு cycle. Okay, and then next cycle, during the next cycle, the program counter, which will be pointing out the current address of the memory device, will be changing into new address in the second cycle. Okay, so second cycle la da program counter new address copy பண்ணும். Okay, the cursor will copy that, so pointing out that new address. So during that period, you will be fetching the second instruction. Okay, pipelining technique fails here because uh, still now your first instruction is not at all executed, just it fetched and changed the program counter to new address, that's all. It's not at all executed. So at that time period itself, it will be fetching the second instruction. என்னாகும், third cycle ல தான் new address ஏ fetch பண்ணும் திரும்ப. ஓகேவா, at that time it will be ignoring the second instruction which you are fetched during the third cycle. Okay, so at that time your pipelining technique fails. Okay, fail to work or fail to execute, fail to match with the go to address, jump address, etc. Okay, that is calling programs, calling subroutine calls. Okay, programs.